Hi everyone, Mallory here with McWane Science Center, and welcome to SciSparks. This looks like just a flat black circle, but would you believe this circle is actually a sphere? It's painted with Black 3.0, one of the world's blackest black paints. To understand how this trick works, we'll need to understand how color is connected to light. Regular white light looks like only one color, white. But when we split the light, we can see that it's actually a combination of all the colors of the visible light spectrum. When white light shines onto an object, the object absorbs some wavelengths of light and reflects others. For example, this apple reflects red light and absorbs all the other colors, so it appears red. And this apple reflects green light and absorbs all the other colors, so it appears green. So that means white isn't really a color at all. It's just what happens when the entire visible light spectrum reflects off of an object. But what happens if an object doesn't reflect any colors at all? If we look at our red apple under red light, because the apple reflects red light, it still looks red. But when we put our green apple under the red light, it appears black. The apple absorbs the red light, but there's not green light to reflect. So black really is the opposite of white. It's what happens when an object absorbs the entire visible light spectrum. Or most of it. Even the darkest objects still reflect some light, and not all blacks are the same. This sample is regular craft paint, and this sample is Black 3.0. When we shine a bright light onto the regular craft paint, it can't absorb all the light, so it has to reflect some back. Black 3.0, on the other hand, can absorb much more light, which means it still looks black. What makes Black 3.0 different? Turns out it has a special formula that lets it hold more pigment than other black paints. And that greater density helps it absorb more light and appear darker. So why did our sphere appear flat? In order to judge an object's depth and contour, in other words, to see it as 3D, our brains rely on reflections and shadows, and we can find those even on really dark objects. Black 3.0, on the other hand, absorbs so much light that there are virtually no reflections or shadows to spot. No reflections and no shadows means no depth, and that means our object looks flat. Researchers at MIT and others are experimenting with materials like carbon nanotubes that can absorb even more light than Black 3.0. These materials could help with things like space telescopes, blocking out the glare from the stars and helping us to see further and more clearly than ever before. Of course, it's also just fun to play around with too. Well, that's it for today. Thank you for watching this episode of SciSparks. If you enjoyed this episode, let us know by leaving us a like. And to catch new episodes as soon as they're released, don't forget to subscribe. Till next time.